Hello and welcome. NVIDIA just showed that the harness, not the AI model, is now the real hero. TechCrunch covered this story on 21st August, and this has gone viral on platforms like LinkedIn and other social media platforms since then. But the question is, why is everyone talking about it, or why is that article has gone viral? Now, NVIDIA has done something remarkably well. It has tackled two problems. First is NVIDIA took the same Claude Opus 5 model that scored around 30% on ARC-AGI-3, which is a benchmark to evaluate AI agents, and put it inside a different agent harness and got it 100% on the benchmark. Now, if you're wondering what ARC-AGI-3 is, then let me explain. So ARC-AGI-3, as I said, is a benchmark to evaluate AI agents, and it tests real intelligence, not just the knowledge. Now, how traditional test happens is you give a question like what is 2 plus 2, the answer you get is 4. So in this way, the information is known and your question is quite explicit, and the AI leverages pattern recognition here to give you the answer. But that's not the case in ARC-AGI-3 benchmark. So here AI agents need to figure out things in an unfamiliar environment. There are no rules given, unfamiliar environment, and requires exploration, reasoning, and learning. So the simplest way to understand ARC-AGI-3 is like giving an AI a video game without telling it the rules and asking it to figure it out how to win. So no rules provided, AI explores, learns, and adapts, and eventually figures out how to win. So that's what the AI agent has done in this case. So how it approaches it, it observes, explores, and then learns patterns and plan and adapt and solves and win. So here in this case, NVIDIA has done is NVIDIA has taken the same Cloud Opus 5 model and got it 100% on this benchmark by putting in inside a different harness. Now, I'll come to more on that. And the second problem that NVIDIA has tackled is the problem of long-running AI agents. So, long-running AI agents is quite a problem right now because the AI agents eventually fail. They get distracted. Now, for example, here in this case, Microsoft published a research, and this is covered in the same TechCrunch article that I showed earlier, that Microsoft published research in April that tested 19 LLMs on long horizon tasks involving document editing and discovered that all the models, including the frontier ones, right? Not the normal models, the frontier ones, fill the documents with errors. Now, if humans produce work like that, they would be promptly fired. So by with this you can understand how important this problem is, which NVIDIA has tackled really well. So in the upcoming video, what I'm going to show is why do long running agents fail, right? And then how NVIDIA has tackled these two problems. So there is some interesting stuff coming ahead. Don't go anywhere. Watch this video till the end. All right. So and I'm going to take first principles approach to explain you this. All right, so let's start from very basics. Now we know the model acts like a brain. Like model is your brain. You give model a text, your input or a prompt, and model returns you an answer. So here model is just answering, but it's not acting. It cannot do anything, right? It's just a brain. It answers, but it cannot act. Now AI agents goes a step further. They leverage model, which obviously is the brain, but then they've got tools around it which acts like hands or limbs, right? And then models obviously acts like brain, and then you've got environment, which is like their world, and then their memory. The agents also have got memory, which acts like long term memory, which helps them remember things. And then they've got feedback loop as well. So this is how typically an agent works, right? So but then the problem here is, if I can sort of diversify, sort of compare vis-a-vis, LLM alone is singleton, forgetful, gets stabbed in a chat window, needs human steering. Whereas EA agent is a multi-step, continuous, stateful, remembers history, right? It remembers history, acts in digital environment, and self-steering. Now, that's what makes the harness. Now, what makes the harness? So, what exactly is the harness here? So, model, as we know, is a brain, and the harness is everything that's surrounding this brain. So, to sum it up like this, the harness is a software wrapper that turns a raw model into an autonomous worker. So everything around this brain is called harness. So tools, context, state, evals, feedback, supervision, recovery, memory, so on and so forth. So the entire wrapper is called the harness. Now, with that in mind, let's try to understand why do then long running agents or long horizon task fails. So the problem with agents that we observed is agents are typically used in to solve complex problems, and they are needed to run for long running days or for longer duration of time. During these times, what really happens is they get distracted and hallucinate. They lose context over time, and then they do not have inability to recover, right? As I said before, Microsoft research showed 19 different LLMs filled documents with errors, right? The thing that I talked about earlier. Now, let's try to understand what is it our end goal, right? We want agents to be in this unbroken loop so that we can do this sustained work, right? They can be in this loop and do our work continuously without failing, or do solve really complex problems. That's what we want agents to do, right? So to solve this problem, what NVIDIA has done is NVIDIA has developed something called AVO, which is the stands for Agentic Variation Operators. This is nothing but agent architecture designed specifically for sustained, long-running or long horizon autonomous work. Now, how a how does AVO work then? So AVO has got something called a supervisor that always keeps a tab on this main agent. So main agent is some is the agent that does the real heavy lifting here, does the real work. And to support that main agent, obviously there's the memory, tools, context, and the environment, feedback, evals, and that iteration goes on. And the supervisor here is continuously guiding the agent, or it gets stuck. It really it acts as a CEO, and it monitors the broad trajectory and nudges the main agent if it gets stuck in a loop. And then there is obviously memory that carries forward past code, compiler outputs, and reasoning. Now, so agent doesn't have to start everything from scratch every time. So this memory is important. So what NVIDIA has done is it has designed this AVO architecture. Now, with leveraging this AVO, NVIDIA has applied it to two different problems, right? One is GPU kernel optimization. The other one is ARC-AGI-3, the one that I just showed before. Now, let's look at the results that NVIDIA has got. So when NVIDIA applied AVO to this GPU kernel optimization problem, that ran for 7 days, 7 continuous autonomous operation, and 500 plus optimization directions explored, right? And 40 committed kernel versions that gave to 10.5% performance improvement over flash attention. And this was done on this BGX B200 hardware. Now, this is a fun thing that so point here is that agent or the agents ran of 7 days continuously. Okay, and it gave rise to 10.5% of performance improvement. Now, another problem that NVIDIA applied, another benchmark, the NVIDIA applied their AVO agent architecture is to this ARC-AGI-3 benchmark, where, as I said before, there are no instruction givens, no rules, no stated goals. The agent must infer how the world works. So pure experimentation. So unknown environment, agent has to observe, experiment, infer rules, act, and then something fails, something works, and then take feedback, learn from it, and then continue. So now, what has happened on ARC-AGI-3 is they've got 100% RHAE, which is relative human action efficiency on the public set, and 183 levels completed, and it worked in 25 environments solved, and then 6,624 environment actions used. So great level performance, right? Now, so to sum it up, the machinery of progress is universal, right? GPU optimization, ARC-AGI. So AI agents have to hypothesize, act, observe, update, and repeat. So the key point here that I want to make in this video is the way, or the direction where this industry is heading. So far, the notion or the belief has been that better the AI model, then you can solve complex problem, right? But that is shifting now. So agent harness is playing a very pivotal role. So open harness offers massive control over accuracy, and cost and performance are dictated by system design, not just the base model. So far it has been assumed that base model is everything, but then the real focus is also on system design now. And as in database you rightly said, you can pick the same model but different harness, and you get significantly more cost if you use the wrong harness. So harness is playing a very pivotal role. So the point is, the model provides intelligence, but the agent determines how effectively that intelligence can be used, or the harness determines how effectively that intelligence can be used. Hope this video was helpful and you found it interesting, and that this was able to give you clarity. In next video I'm going to show hands on as to how to really this hand harness works. All right, thank you.